Good evening, guys. Fluid mechanics. Let's solve the pump problems in a far simpler approach. So, if you remember, we solved this a two tanks and pumps combination problem with the helps of Bernoulli equation and then the discharge continuity. So we just jot down the Bernoulli equation for point between point 2 and 3 and get the velocity in the pipe. So pipe velocity, and then Q is A times V, and based off Darcy-Weisbach equation, HF is head loss is FL over the V squared over 2G. When we have the velocity, we can easily calculate. F is known, L is known, D is known, and G is 32.2. And then if you replace in the formula of power, that's gamma Q total head over 550 times efficiency. Now this time we want to solve it in a way easier approach. So in this solution, again, we have the same problem, and I will, if you don't know the problem, I will post the link for that one as well. We were working around to calculate the horsepower of the pump which send the water from tank 1 to all the way up to elevation of 1480 feet, 1480 feet in tank 2. So to do so, we have two approaches, solution 1 and solution 2. We solved the problem with the total dynamic head last time, and this time solution 2 is based off pump head. We are focusing our attention on the pump itself. So in pump head approach, we can directly jot down the hydraulic gradient line between point 1 and 3, including, so again, last time we start with 2 and 3. Now this time we just jump here and considering the pump as well. So HGL 4.3 is equal to HGL 2 plus HG plus head loss from 3 to 2. Again, for calculation of this part, yet you need to calculate the velocity from this part. That's the only extra part you need to do, but yet make it far simpler. So, like solution 1, it just gives you HGL 3 halfway through is the elevation of that point plus pressure times 2.31, conversion of psi to feet of water, then equal to height of watering point 2 plus head loss from 3 to 2, which is the halfway through the uh, uh, pipe. So we just divide the length of 4,500 feet to 2, and the rest it just gives us 2250. Likewise, we are looking for velocity, and it just gives us velocity is equal to 6.32 feet per second like previous solution, and from here the difference begins. So now we'll write the hydraulic gradient line between point 1 and 3, including pump itself. That's the big point. So as soon as we have this part, we can calculate H pump directly. So what does it says? It just says the only unknown in this equation. It just says if you jot down the Bernoulli's equation for point 1 and 3 halfway through, it just gives us HGL hydraulic grade line at 1 plus pump head. The power of head is equal to hydraulic grade line in halfway through plus head loss from 1 to 3, again halfway through. So the only unknown in this problem, because we already know the velocity from the other half, so only unknown is just the pump head, and it just gives us a head of a power of pump is equal to 154.6 feet. Wow, that's very interesting result. So if you make a comparison with solution 1, in solution 1 which we had the approach with the total dynamic head of the problem, And in solution 2 we had the pump head, and if you remember, TDH or total dynamic head in part 1 was 85 plus, which was lift plus 69.6, which is major head loss within the pipe, and it just gives exact numeric value of 154.6 feet of water. And H of pump came to be the same numeric value. One can say, wow, it just says total dynamic head is equal to pump head. Mhm. So, in other words, one can say the pump must overcome the head losses due to friction and lift together. To That's why the head of pump is exactly equal to those friction plus lift heads. That's why as soon as we know what is the head of pump, the problem is done. So TDH is this amount, and that's equal to H of mm, head of pump. So as soon as you have like this and replace in the formula for HP, which is again gamma Q H total over 550 times eta, you can have it like in solution 1 we used total dynamic head, and in solution 2 we use the H of pump, which is exactly the same numeric value. They are identical. Thank you will solve more problems. And also there is an interesting note too. You can also use Bernoulli's equation for directly from point 1 and 2 instead of 2 and 3, instead of 1 and 3. So just jump from 1 to 2. But again, don't forget we need to use the Bernoulli's equation for point 2 and 3 to get the velocity of the pipe. Because if you use it here, there are two unknown, velocity and head of pump. So in either case, you need the Bernoulli for point 3 and 2 halfway through to the very end. Thank you. We'll solve more problems.